Okay, this is probably going to be a long lesson here, so hang in there. 9.3a is the lecture title. I can find the trigonometric values for a quadrant angle and for angle in standard position whose terminal sides go through a specific point. I can find the reference angles and use them to find the trigonometric values. If a acute angle within the triangle is not between 0 and 90, you can still find the trigonometric values for that triangle. You can still use a right triangle if it's not a multiple of 90. If they are a multiple of 90, there's a little bit different process. We'll go over that a little bit later in the lesson. So, for example, let's take an angle that is in standard position. Let's put it in quadrant 2. And this angle is something like that. And it has a point that it ends on. Let's call that -3, 4. Okay, so let's look at the procedure for finding the trigonometric values for this angle that is not between 0 and 90. So let's look at the procedure. From a point on the terminal side of the angle, which we have right here, -3 and 4, draw a line segment that connects this point and the x-axis, and it's perpendicular. So we're going to take and draw a line from the point of interest straight down to the x-axis such that I have a right angle with the x-axis. Now, it doesn't matter if I am in, let's say, beneath the x-axis, you're still going to draw it up to the x-axis and create a right triangle, okay? Here's the right triangle of interest now that I'm interested in. Now, we are going to focus on the trigonometric values of our reference angle, which will be this little angle here, okay? So we're going to label the lengths of that triangle, and the y value, which is given right here, is a +4, and the x value is a -3, and the negative sign is important, okay? So it says so right here, can be negative. All right. We have to find our hypotenuse of that triangle. And so 4 squared plus -3 squared, and then take the square root. That would give me a +5. That hypotenuse, which will always be positive, even if I have a negative leg because I square it. Again, the hypotenuse is always positive. Then we're going to use that little reference angle that I have inside. Okay, this little reference angle, and we will use that reference angle and find our trig functions. So for example, sine of that reference angle, I'll call that reference angle beta, is equal to, and actually, yeah, I'm gonna say sine of theta, and because actually the value that I'm finding, even though I'm using my reference angle, will be the same sine value of theta, okay? And that's why we have to have these negative signs. So opposite over hypotenuse is 4/5. So the sine of, even though I'm using that little small reference angle, the sine of theta is actually 4/5. The cosine of theta is equal to the adjacent, which is -3, over the hypotenuse is 5, and so forth. So this is just like we would do before, except we are paying very close attention to the length of each side and whether or not it's positive or negative. Okay, so we're using the reference angle, but we are, it will actually give us the value of our the angle of interest. So here we go. Let's do some problems. So we have the terminal side of an angle theta in standard position. It contains the indicated point. Find the exact values of the specified trig function. So we're not going to use our calculator because our calculator will give us a decimal, and that will not be an exact value. So I have the point -3, 2. So -3 comma 2 is going to give me somewhere in this location right here. And so I have drawn my line to the origin. I'm going to label my X length, which is -3. I'm going to label my Y length, which is +2. I have dropped that line down to the X-axis, which is going to give me a right triangle. I will use Pythagorean theorem to find the length of my hypotenuse. So I'll take 2 squared plus 3 squared and take the square root, and that will give me the square root of 13. That is a positive value. I am going to focus on my reference angle inside that triangle, which is the angle that line makes with the origin to the x-axis, and that is going to give me the angle or the value of tangent, for example, of theta. So here we go. Tangent of theta, as I've said, I always write SOHCAHTOA when I'm working with this, so I don't forget. So tangent of theta is opposite over adjacent. Focusing on my reference angle inside that triangle, I have tangent is equal to 2 over my adjacent, which is -3. So the answer is 2, -3. I have cosecant, which is related to sine. So instead of opposite over hypotenuse, I have hypotenuse over the opposite, which will be 13 over 2. Again, that is the cosecant value of theta. I'm using my reference angle to do so. And because I have -3, oops, don't want to do that. That's why it helps, it's related to theta. All right, cosine of theta is adjacent over hypotenuse. Looking at my reference angle, adjacent is -3 and hypotenuse is the square root of 13. And if we were to get the radical out, that'll give us -3 times the square root of 13 over 13. Okay, so let's take B, for example. I have 4, -1. So I'm going to actually draw that, and that will be in the 4th quadrant. And so there's my dot that has a point of 4, -1. And here is my line to that point from the origin. Now I need to create a right triangle with the x-axis, and we're going to evaluate my trigonometric functions of my reference angle, and that will give, and then I'll label my sides. And so what do we have for side lengths? I have, this is a +4, this is a -1, and then I will use Pythagorean theorem for squared. 16 plus 1 squared, 17, square root of 17 is my hypotenuse side. That is always positive. And then we can then start to evaluate our functions. Sine of theta is opposite over hypotenuse. The opposite of my reference angle is -1. The hypotenuse is square root of 17. And I can multiply both sides, or top and bottom, by the square root of 17, and I will get the square root of 17 over 17 to get the radical out of the bottom. Tangent is opposite over adjacent. That will give me -1 over 4. Secant is related to cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And so that'll give me the square root of 17 over the adjacent side, which is 4. Okay, so here we go. C, I'm going to draw my point, -2, -5. And so my point will be somewhere in here. I'll call this -2, -5. I will draw my terminal in from the origin. I'm going to drop or create a right triangle with the x-axis. And there's my right triangle. We are going to use our reference line, or a reference angle, excuse me, that is created with the origin, and label our sides. And so this is my y side, which is -5. So this is obviously not drawn to scale. This is -2. I then take 2 2 squared plus 5 squared, take the square root of that. That gives me square root of 29. And then I will find my trig functions. Cosine is adjacent over hypotenuse. Once again, I'm looking at my reference angle in the inner right here. And so cosine adjacent over hypotenuse, the adjacent is -2. The hypotenuse is square root of 29. And if I multiply top and bottom by the square root of 29, I will get -2 times the square root of 29 over 29. Cotangent is related to tangent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. And that will give me adjacent is -2. Opposite is -5. So we will get 2/5 for cotangent of theta. He left the negative. I think that's a mistake, but okay. I'm pretty sure those negatives cancel. All right, cosecant is related to sine. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. So we will have square root of 29 over the opposite, which is -5. So -29 over 5. It's a negative fraction. Yeah, I'm sorry, I'm still focusing on a mistake on one of my pages. All right, so how about D? Why don't you try it yourself? Pause the video. Welcome back. So we will take our axis. We'll find the point -3, 1. That will be somewhere here. And we will draw our line to our origin, label the point -3, 1. So create our right triangle with the x-axis. This length is -3. The height is a +1. I got that from these two locations. And then I will use Pythagorean theorem to find the length of the hypotenuse. And 3 squared plus 1 squared is 10. Take the square root is square root of 10. Then I will use my trig functions, and I will focus on my internal reference angle with the origin. And I will say, okay, secant is related to cosine. Cosine's opposite over hypotenuse. So secant is hypotenuse over, I'm sorry, cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. So I have square root of 10 over the adjacent of my reference line or reference angle, which is -3. And there is our answer. Cotangent is related to tangent. So we're going to get adjacent over opposite. Adjacent is -3. Opposite is 1. So the answer is -3. Sine is opposite over hypotenuse. So we get 1 over the square root of 10. And that will simplify into the square root of 10 over 10. Okay. All right, if a point is on a unit circle, just so you know, is a circle that has a radius of 1, okay? The point is exactly 1 unit away from the origin. So it is possible to simplify the previous calculation since the hypotenuse of the triangle drawn perpendicular to the x-axis will be 1. So again, the radius is 1. So if I were to have this circle go around, it will always have a hypotenuse of 1 unit. Okay, that is a unit circle. And so you'll see the hypotenuse is 1. Okay. In cases like this, since sine is a y value and cosine is an x value and the tangent is y over x. So let me give you an example of why that is. So we see that sine of theta, which sine is opposite over hypotenuse. And so that will be opposite, which is the y value over the hypotenuse is 1. So the sine is the y value. Cosine, for example, is adjacent, which is x over the hypotenuse, which is 1 because it's on a unit circle. So the cosine is the x value of this point. Okay, this point is x comma y. And then we have tangent, which is opposite over adjacent. So that will be y over x. All right. So again, if you know that it's on a unit circle and you know its point, you can quickly ascertain the cosine of theta and the tangent of theta with just the y and the x coordinates. So let's do some problems. Suppose that theta is an angle in standard position whose terminal side intersects the unit circle. So you're looking for this designation, this unit circle, at the specified point. Find the angle in standard position whose terminal side intersects the unit circle at the specified point. So we know this is my x value, comma, this is my y value. Sine is the y value, so that is 15 over 17. Cotangent is related to, give me 1 second, please. Sorry for the interruption. Cotangent is related to tangent. Tangent is the y value over the x value. So cotangent is x over y. And so cotangent is -8/17 over the y value of 15 over 17. I can multiply both top and bottom by 17, and I will get -8 over 15 as my answer. Secant is related to cosine, except flipped upside down. Cosine is x because it's on the unit circle. And so in this case, it'll be 1 over x. And so it'll be 1 over, or just flip the x, 17 over 8, -17 over 8. Okay, so let me show you. You could actually decide that you wanted to draw this triangle, and the x side is negative, the y side is positive, and this unit circle has a length of 1 for the hypotenuse, and we know that the x is -8 over 17, and the y is 15 over 17. And then you can use this internal reference angle and then answer the questions that were asked. Sine, which is opposite. So here's my opposite over the hypotenuse of 1. And cosine, or sorry, cotangent is the inverse of tangent. So instead of opposite over adjacent, it's adjacent, which is -8/17 over the opposite, which is this positive 15 over 17. But hopefully what you really need to do is understand that if it's on the unit circle, sine is y, cosine is x, and tangent is y over x. It will save you a tremendous amount of time. Okay, so this is my x value, this is my y value. I'm asked for the tangent of theta, and tangent theta is y over x, and so I will get -5/6 over -√11 over 6. I can multiply both top and bottom by 6. I get -5 over -√11. The negatives will cancel. And I can also multiply the top and bottom by the square root 11. I will get 5 square roots of 11 over 11. Sine is y, and so sine of theta is equal to the y value, which is -5/6. Cosine is x, and so cosine of theta is -√11 over 6. Okay. All right, well, try 2 yourself. I'd say pause the video and see if you're right. Welcome back. Once again, this is my x value. This is my y value. Let me put that where you can see it a little better. X and y. So I have cosecant, which is related to sine. Let's go ahead and rewrite them. I have to see these sometimes. This is why I write them. All right, that's an A. Fix that. There we go. All right. Back to the problem. Cosecant's related to sine. and sine is my y value. And so cosecant will be the inverse of that. And so that'll be negative 61 over 60. Tangent is y over x. I always have, yeah, y over x. And see, I even have to memorize this, y over x. So I get negative 60 over 61 divided by negative 11 over 61. Multiply top and bottom by 61. 61 cancels and my negatives cancel. So I get negative, 60 over 11. Cosine is my x value, and I get a negative 11 over 61. Okay. Again, you can draw out your triangle and it's on unit circles, so your hypotenuse is 1, but it would be better to memorize the fact that cosine is x, sine is y, and tangent is y over x. All right, I got cotangent, which is related to tangent. Tangent is y over x, so cotangent is x over y. So negative square root of 3 over 2 divided by 1 over 2. 2's will cancel if you multiply top and bottom by 2, and you will get negative square root of 3 over 1. So it's negative square root of 3. Secant is related to cosine, and cosine is x. So we are going to flip it. So it's going to be 1 over x, or just take the x and invert it. So I have 2 over the square root of 3, and then multiply both top and bottom by the square root of 3. You will get negative 2 times the square root of 3 over 3. Cosecant is related to sine. So sine is y, and we're going to invert it. So I take my y and I take 2 over 1. So the answer is 2, because cosecant is 1 over y. Secant is 1 over x. Cotangent is x over y. Let's just say cosine is, again, your x value. Tangent y over x. Cosecant 1 over y, because it's the opposite of sine. Okay. All right, if the terminal side of the angle in standard position is on the x or y axis, the angle is called a quadrant angle. Okay, we'll have to deal with those angles a little bit differently. It's not possible to draw a right triangle perpendicular to the x-axis in that case. So for the quadrant angle, it is helpful to recognize the following. Use only points that are 1 unit away from the origin. So it's essentially on the unit circle. So for example, if I am at 90 degrees, I have, that's actually not 90 degrees. The first one is at 0 degrees. That has a point of an x value of 1 and a y value of 0. The next one would be at 90 degrees, and that would have a point of 0x and 1 for the y. If I'm at 180 degrees, that has a negative 1x value and a 0y value. If I'm at 270 degrees, I will have a value of a 0 for x and negative 1 for y. And then we can recognize that sine is a y value, cosine is an x value, and tangent is y over x, and use the same approach that we did before. And then, of course, remember the fact that cosecant, secant, cotangent are reciprocal functions for sine, cosine, and tangent. So and then this just repeats what we just did. And then I will do some problems. So we are going to find the sine of 180 degrees. If 180 degrees is located on, what do we call that? A quadrant angle. It's located on the negative x-axis. And that point we're going to assume is negative 1, 0. Sine is the y value. The y value for that point is 0. So sine of 180 is 0. Tangent of 3 pi over 2. It is very useful to remember that this is pi over 2. not useful, but almost required, pi. And then I have to go another half. And so this is 3 pi over 2. And then eventually I will have 2 pi if I've gone 360 degrees. Okay, so where are we located? We are located at 3 pi over 2. So I'm on this negative y-axis. And so I have a 0, -1. Tangent is the same as y over x. Y is -1, x is 0. Can't divide by 0, so this is undefined. And that is possible. We have certain values that are undefined. Secant of -pi. So -pi, I'm going to go to the negative, which is clockwise. An angle of pi, so that is in radians. Pi is the same as 180 degrees, so it's located on the negative x-axis. That value, that point, you're going to assume has a -1 for x and 0 for y. Secant is related to cosine. Cosine is the x value and secant is 1 over x. What is the x? It's -1. So 1 over -1 is -1. There's your answer. All right, try the next 3. Welcome back. So let's figure these out. I have cosecant of -pi over 2. Here's -pi over 2. This has a point of 0, -1. Cosecant is related to sine. Sine is my y, and cosecant is 1 over y. And y in this case is -1. So 1 over -1 will equal a -1. 90 degrees is located right here. And that should have a value, if I'm on the unit circle, of 0, 1. And cosine is related to my x value. And cosine in this case will be 0. Cotangent of 0 degrees. So here I am at 0 degrees. I will have a 0 x value and a 0. Oh, no, evidently I can't. I will have a 1 for my x value, 0 for my y value. Cotangent is related to tangent. Tangent's y over x. So cotangent is x over y. My x value is 1. My y value is 0. So this is undefined. Alrighty, let angle theta be in the quadrant 3, such that cosine of that angle is -5/8. Find the exact value of cosecant. So we're not using our calculators. We have to use our knowledge of how to use reference angles and triangles to get that exact value of cosecant theta. So let's find our, create our angle. We know that cosine of some theta, and this theta is in the 3rd quadrant. So I am in this quadrant, and I'm going to create my triangle with the x-axis. I'm going to focus on my reference angle. They have told me that the cosine of theta, and cosine is the adjacent over the hypotenuse. So the adjacent side has to be my negative. The hypotenuse has to be 8, and that will always be positive. And then I will use Pythagorean theorem to find the y value. So we know that 8 squared equals -5 squared plus y squared. And if I solve for y, I will get the square root of 39. So I have the square root of 39. Now notice that the y value is in the negative direction. So that is a negative square root of 39. That's very important to remember that. Now I can find the cosecant of theta. Cosecant is related to sine. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So we know that the cosecant of theta sorry for my handwriting, the cosecant of theta is equal to the hypotenuse, 8, over the opposite, negative square root of 39. We will just rearrange or simplify that because radicals in the denominator is not considered simplified. Multiply top and bottom by the square root of 39, and we will get 8 times the square root of 39 over 39, and this is still negative. All right, one more, and then that'll be it. Why don't you try this one yourself? Welcome back. Let angle theta be in quadrant 2. So let's draw. I'm in quadrant 2. Here's some angle that we have in standard position. We are told that the sine of that angle is 2/3. So sine, and we're going to create our triangle with the x-axis. We're going to use our reference angle, which gives us the same value. So we know this is my opposite. This is my hypotenuse. So the opposite is 2, the hypotenuse is 3, and then we will use 3 squared equals 2 squared plus x squared, and we will find our x value. And that will be the square root of 5. And we will know that it's negative because it's to the left of the origin. Now I can use this information to find the exact value of cotangent, cotangents related to tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So cotangent theta is the adjacent to my reference angle, which is negative square root of 5 over the opposite, which is 2. And there is my answer. All right, I hope my lesson made sense. Please pay attention to Alex. Alex is crucial for this unit. And I will see you in the next lesson.